Lesson 1: Introduction to Computer Hardware. Welcome to our computer hardware course. I'm excited to guide you through the fascinating world of computer components and systems. In this first lesson, we'll explore the fundamental building blocks that make up every computer you use. Whether you're looking to troubleshoot problems, upgrade your existing system, or build a computer from scratch, understanding hardware basics is your essential first step. What is computer hardware? Let's start with a simple question: what exactly is computer hardware? Computer hardware refers to all the physical components of a computer system, everything you can touch and see. This includes the screen you're looking at, the keyboard you type on, and all the chips and circuits inside your computer case. Hardware versus software. It's important to distinguish between hardware and software. Hardware is tangible, you can physically touch it. Hardware has fixed functionality, is susceptible to physical wear and tear, and includes components like your CPU, RAM, motherboard, and storage drives. Think of hardware as analogous to a car's engine and frame, while software would be the driver and GPS system. Both need each other to function properly. Computer hardware can be organized into several main categories. 1. System unit components, the parts inside your computer case. 2. Input devices like keyboards and mice. 3. Output devices such as monitors and printers. 4. Storage devices including hard drives and SSDs. 5. Network devices like Wi-Fi cards and Ethernet cables. Software, on the other hand, is intangible, it exists as digital code. Software can be easily updated and modified, doesn't physically degrade, and includes your operating system, applications, web browsers, and games. A simple way to understand this relationship: your TV is hardware that displays movies, which are software. The motherboard, your computer's central hub. At the heart of any computer system is the motherboard, the central circuit board that connects everything together. Think of it as the nervous system of your computer, facilitating communication between all components. Your motherboard features several key elements. A CPU socket where your processor is installed. RAM slots for memory modules. Storage connectors for hard drives and SSDs. Various I/O ports like USB, HDMI, and audio connections. A chipset that manages data flow between components. The CPU, your computer's brain. The central processing unit, or CPU, is often called the brain of your computer. It processes all the instructions from software and generates the outputs. More chefs' cores mean more orders can be completed simultaneously. A CPU's performance is influenced by several factors. Number of cores: more cores allow for better multitasking. Threads, virtual cores that enhance multitasking ability. Clock speed measured in gigahertz, higher numbers generally mean faster processing. Cache memory, fast memory that the CPU can access quickly. To understand how a CPU works, imagine a restaurant kitchen. The chef represents your CPU, processing orders or tasks. RAM and storage. The memory systems. Computers use two primary types of memory. RAM, or random access memory, functions as your computer's short-term memory. It stores data that's actively being used, allows for smooth multitasking when you have enough of it. Storage devices serve as long-term memory and come in two main varieties. HDDs, hard disk drives, traditional mechanical drives that offer high capacity at lower costs. SSDs, solid-state drives, newer technology that's faster and more reliable, but typically more expensive per gigabyte. Here's a helpful analogy. RAM is like your desk workspace: the larger it is, the more projects you can work on simultaneously. Storage is like your filing cabinet where you store documents for later use. Power supply. The energy source. Every component in your computer needs power to operate, and that's the job of the power supply unit, or PSU. It converts AC power from your wall outlet into DC power that computer components can use. When considering a power supply, pay attention to wattage: must meet or exceed your system's total power needs. Efficiency rating: higher efficiency units save energy and generate less heat. Available connectors ensure compatibility with all your components. A quality power supply is crucial for system stability and can protect your valuable components from power-related damage. How everything works together. Now that we've covered the main components, let's see how they all work together. You provide input through a device like your keyboard. This signal travels to the CPU, which processes the information. The CPU uses RAM to temporarily store and quickly access data. Processed data can be saved to storage devices for long-term keeping. Results are sent to output devices like your monitor. The power supply provides electricity to all components. The motherboard facilitates communication between everything. It's similar to ordering food at a restaurant. You tell the waiter, motherboard, what you want. The waiter takes your order to the chef, CPU, who uses ingredients, RAM, to prepare your meal. The finished dish is served to you, output, and the restaurant's utilities, power supply, keep everything running. The recipe itself is stored in a cookbook, storage. Conclusion. Congratulations! You now understand the basic components that make up a computer system and how they work together. This foundation is essential whether you're troubleshooting problems, planning upgrades, or preparing to build your own PC. In our next lesson, we'll explore how to select compatible components and consider your specific needs when building or upgrading a system. Thank you for joining this first lesson. I look forward to continuing our hardware journey together.